Welcome to the Exercise Solutions for Measurement and Physical Quantities, Lesson 1 for Grade 10 students. Our first multiple-choice question asks for the SI unit of work done. The correct answer is joule, or J. Work is a derived unit calculated as the product of force and displacement. Next, we ask what fundamental units are. The answer is independent units. Fundamental units are the essential building blocks of measurement, such as the meter and the second, which do not rely on other units for their definition. Which units make acceleration? Since acceleration is measured in meters per second squared, or meter per square second, the correct fundamental units are meters m and seconds s. The SI unit of force is the Newton N. Based on Newton's second law, the fundamental units found in force are kilogram, meter, and second, expressed as kilogram meter per square second. Moving on to the fill-in-the-blank section. The SI unit of length is the meter. Pascal is a derived unit. Derived quantities depend upon fundamental quantities. Reference standards used to measure physical quantities are units. Hypothesis is the statement of an experiment. In the short answers, Part 1, Section. Physical quantities are quantities that can be measured, like length and time. Independent variables are factors that are changed, such as temperature. Dependent variables are the effects that rely on independent variables. The difference between an independent variable and a dependent variable is that the independent variable is the cause, and the dependent variable is the effect. Units are reference standards used to measure physical quantities. In short answers, Part 2, fundamental units are independent units, like the meter and kilogram. Derived units are units derived from fundamental units, such as meter per second and N. The fundamental units in Pascal are kilogram, m, and s. We use fundamental units to test homogeneity because only the same units can be added or subtracted, ensuring equation consistency. For the case study on ALOC's components, the independent variable x is the cause, which ALOC changes. The dependent variable y is the effect, the variable being tested and measured. We assume x is changed to directly observe the effect on y. In Abrides' ball experiment, the independent variable is the force applied. The dependent variable is the distance the ball covers. Controlled variables include the same ball type and weight, the same surface, the same kicking technique, and no wind interference. Kuntha's path scenario compares road length versus effort. The independent variable is the length of the road, and the dependent variable is the total effort applied. Controlled variables are the same height, same person, same speed, and same load. In the heat absorption experiment, the independent variable is the color of the object. The dependent variable is the amount of heat absorbed. Controlled variables include mass, sunlight duration, and shape. The hypothesis is that darker colors absorb more heat than lighter colors. Gunga's nutrition case study identifies the amount of food eaten as the independent variable. The dependent variable is the gain in body weight. Controlled variables are the type of food, physical activity level, age and gender of the subject, and the duration of the experiment. The analysis of tap knob rotation asks, how does the degree of rotation of the tap knob affect the rate of flow of water per unit time when water pressure is kept constant? This question links the independent variable, which is rotation, to the dependent variable, the flow rate. Finally, the Give Reasons section explains why joule is a derived unit, depending on fundamental units like kilogram, m, and s. Time is a fundamental quantity because it is independent. Temperature is an independent variable for solubility because it is intentionally changed to observe its specific effect. Question F focuses on unit breakdown. The derived unit Pascal, or PA, involves the fundamental units of kilogram, meter, and second. Its base form is expressed as kilogram per meter per second squared, or kilogram squared. Now, let's examine the homogeneity check for equations A through circa. Each equation shows that the units on the left-hand side and right-hand side are consistent. For example, ns equals ut, both sides equate to meters, and inverse squared equals u squared plus 2as, both sides are meters squared per second squared. Continuing the homogeneity check for equations D and E. For t equals 2 pi times the square root of L over g, both sides result in seconds. For versus equals the square root of p over d, both sides result in meters per second. In conclusion, all given equations are dimensionally correct. This video has utilized several images from online sources. Here are the image sources and their corresponding websites, including vecteezy.com, mdpi.com, blog.bentley.com, and raisingglobalcitizens.com.